Oh, you're back. Still have some questions, huh? The most important thing is that now we have a chain list that's pretty hard to hack. Mike, if you're watching this video, just know, I don't trust you. In fact, I trust very few people. Because when it comes to money, you can't trust anyone. But here's the issue. My friends love the idea of this chain list, and now they want to use it. Who's going to handle the accounting? Mr. Raccoon?
No. Mouse, will you do it?
Yes.
Anyone but him.
Our ancestors created the banking system and decided to trust it. After all, there are laws, licenses, and insurance. Let's say we figure out who manages things among ourselves. But what if the whole town wants to use our technology? What if the entire country does? Then we can't trust anyone at all. That's why a different approach was invented. Everyone will have their own copy of the list, so Mike would have to team up with not just some hacker, but Santa Claus himself to sneak into every house with a copy. And who knows, someone might have hidden extra copies that no one knew about. This is decentralization. Downsides? Of course, you'd have to call everyone to make an update. But if the participants are heartless machines, it's not a problem anymore. In our system, there is no single point of trust. Everyone only trusts the information they have. That's the main rule of any decentralized network. I want to buy a laser pointer. To confirm the purchase with a card, as the bank asks for my PIN. If I enter it correctly, the bank checks if I have a couple of dollars in the account and either approves or denies the transaction. Those records we talked about before are also a type of transactions, but we don't know who made the transaction. So how do we make sure Mike didn't secretly add a record saying, "You owe Steven $100? That's where public and private keys come in. Don't panic. It's simpler than it sounds. Let me explain. On your computer, you generate a pair of numbers, a public key and a private key. The private key is super secret because it can decrypt what's written with the public key. It works the other way around too. If you share your public key, your friends can use it to encrypt a message that only you can decrypt with your private key. Plus, they can use your public key to verify that the data was encrypted by your private key without actually decrypting the data itself.
Yeah, I get it. This sounds tedious. That's why we have online wallet services for you. I'd recommend these.
Now, we're on decentralized internet. Still, you can trust anyone. The transactions are signed with the private key and along with the public key are sent to a special place, the pool of unconfirmed transactions. Now, anyone in the network can verify that you were the one who initiated the transaction using the public key. This archives transparency and security. Banks used to be responsible for this, but now it's all computers and math. By the way, your public key is your crypto wallet number. So, you can create a wallet for any cryptocurrency without even going online. Does the concept of balance even exist in the blockchain? Remember when I mentioned the pool of unconfirmed transactions? Why do we need this in-between place if we already have the signed transactions? Why not just write them directly to the blockchain? Well, talk about that in the next episode. For now, like, subscribe, share with your friends, and see you next time. Good luck.